Working with absolute value equations. So a key note here is when we take the absolute value of a negative number, it comes out as a positive. So when I have the absolute value of a negative 7, it's going to equal positive 7. And the absolute value of a positive number comes out as a positive number. So the absolute value of 7 equals 7. So when you notice this, if I have, instead of a number inside the absolute value, I have a variable inside, and I'm asked, what is the value of x? And in this case, I have two values that x could equal. X can be that positive 7, or x could also be the negative 7, because when I take my answer and plug it back in, I will get the result of a positive 7. So when you have an absolute value, you have more than one solution. You have both the positive and the negative of what the answer equals. So when you have an expression inside the absolute value and it equals some number, you're going to have two solutions. And the two solutions will be the expression equal to the positive and the expression equal to the negative of what's on the outside. So when you have an absolute value equation and you're asked to solve, you're going to take the expression that's inside the bars out. You're going to set one equal to the positive of what's on the outside and one equal to the negative. So the only time you will not have two solutions is when the C value equals 0. Working with absolute value equations, we will have two solutions. So when you have an absolute value equation and it equals some positive number, you will set it up with the expression that's inside the absolute value bars equal to the positive or the value that's on the outside, and you'll also set that expression equal to the negative of what's on the outside. So you have two solutions. You'll take it and you'll solve. Now one key note here is when your C value, when the absolute value equation equals 0, there is only one solution because there's no negative 0. Another key note here is that an absolute value equation can never equal a negative because when we have an absolute value, it always comes out as a positive. So if you have an absolute value equation equals a negative, there's no solution. So here's an example. I have an absolute value equation, and what's inside is that x minus 4, and I need to solve for x. Well, in order to solve for x, I need to take the expression out and set 1 equal to the positive what's on the outside, positive 8, and 1 equal to the negative of what's on the outside. So I end up getting the x minus 4 equals 8, and the x minus 4 equals a negative 8. And now I'm going to solve each one of these separately, and it's a one-step equation. So I'm going to add 4, and I'm going to get x equals 12, and I add 4 to the second, and I get x equals a negative 4. So my two solutions for this absolute value equation will be 12 and negative 4. And you could always take the values and plug it in to the original expression and evaluate. Pause and try. So again, you're taking the expression out, setting 1 equal to the positive and 1 equal to the negative of what's on the outside. And now this is a two-step equation. I'm going to add 5 to both sides, and then I'm going to divide through by 2, and I get one of my solutions is x equals 7. I do the two-step equation, I add 5 to both sides, and I get x equals a negative 2. So my solutions here are x is 7 and x equals a negative 2. Pause and try. So my solutions here are x equals 7 and x equals a negative 2. Pause and try. So again, you cannot have an absolute value equal to a negative. So in this case, there's no solution. So this next example, we have an absolute value, but we have things with it. So whenever you're dealing with absolute value equations, you have to first isolate the absolute value expression, which means you have to get the absolute value by itself. And you have to do what you do in the equation. This next example, notice that we have an absolute value equation, but we have things with it. You can't remove the absolute value bars until it's isolated. So the first thing you're going to need to do is isolate the absolute value. And in order to do that, you have to do the inverse operations with the things that are around it. So the first thing I want to do here is get rid of that minus 5. So I'm going to do the inverse operation by adding 5 to both sides. So I end up getting this 3 times the absolute value of 4x minus 1 equals 15. Now notice here that 3 is attached to the absolute value bars, but it's not the distributive property. You can't put something into the bars. So the first thing you got to do here is get rid of. So notice here that I have 3 attached to the absolute value bars. And in order to work with it, so notice here I have 3 attached to the absolute value bars. Now this is not the distributive property, because with absolute value bars you can't put something inside it. You can only take it out. So when we have a 3 attached to the absolute value bars, you have to get rid of it by doing the inverse operation. And 3 is being multiplied to it, so the inverse operation would be division. So you have to divide through by 3 to get the absolute value expression by itself. So now that we have the absolute value isolated and it equals a positive number, I can solve. Again, you're going to take the expression out, set 1 to the positive, 1 to the negative, and solve. And this is a two-step equation. When I do the work for it, I'm going to add 1. I'm going to end up with 4x equals 6. I divide through by 4, and I'm going to simplify that fraction to 3/2. The second one, when I add 1, I end up getting a negative 4. Divide through by 4, and I get a negative 1. Pause and try. So the first thing you're doing is isolating that absolute value. You add 3 to both sides. Then you divide through by 5, and you get that absolute value by itself. You set 1 equal to the positive, 1 equal to the negative, and you solve the two-step equation. So in the first one, you would subtract 1 from both sides. So you get 2x equals 4. Divide through by 2, and you get x equals 2. The second expression, you subtract 1, you're going to get 2x equals a negative 6. And then you'll divide through by 2, and you get x equals a negative 3.